Strafe.
Strafe. What's strafe?
Or stifle. Stifle.
Oh, stifle. Strafe. What are you upset about?
Stifle. Stifle. I'm stifling. That's what Jason says instead of shut up. Stifle.
Strife. It's really sad you feel strife in my class.
No, oh, never.
Last thing I work. All right. Get this guy fired up. Get your guesses in here.
I didn't even vote.
You don't have to yet. You have to November 4th or whatever.
Yeah. No, on that thing.
Oh, on this. I'm sorry. You meant vote in a more specific.
No, I did.
You meant a more specific vote.
Remember, I don't ride my bike helmet.
Oh, I'm just switching my thoughts.
Let's say that again. Say that again. Are you sure?
I said my thoughts are funny.
Oh!
We played with them.
Oh, good. Oh, you can always funny them back. That's what's good. That's what's good about it. I love the TI for that respect. In that respect, the Excel does better graphs, but the TI gives you more kind of finagleability, if that's a word. It's not. It's made it up. But finagleability. You can get in there and mess with the widths. Now I'm going to go ahead and just turn a histogram on first. Now you see how I have mine set up? I've got it on, histogrammed, L1, L2. Does this sound right? Does this sound right for the data we have? It has to be, right? It has to be L1, L2. Tell me why again. Why is it not L11? Why is it not L11?
Because we have data in the second one.
Because we have good. We've got the data in the X column and we've got the frequencies of what you guys voted for in the right. If we put L11, how many people is the TI going to think were in the room?
1. Oh, no.
Assuming we put that in L1, 69, 70, 71, 72, 73, it's going to think there are 5 people in the room. One person says 69, one person said 70, one person said 71, one person said 72, and one person said 73. You got to tell it L2, that way it knows to count 70 10 times. Does that make sense? You guys buy that logic? Okay, good. So I'm going to go ahead and hit zoom 9 to get myself a graph, and then I'm going to finagle. Because you see that gap that's there? It's strange to have a gap. Don't you? L1, L2. Watch it. See that gap? That's strange, isn't it? Strange to have a gap. There shouldn't be a gap. That's because your scale is fractional. It's made your scale 0.8. How far apart are our bars, friends? They're 1. Change it to 1. Why does the TI do this? I don't know. It's got some algorithm it follows. I don't know. That's why I like finagling. To get in there and change it. I'm going to change it to a 1. I'm going to press graph again. That looks more like our data does it. And you see it's cutting that last bar off. Maybe we make it a little bit wider, bring that last bar in all together. How about 74? Now I see everything. Oh, sorry, yes, Candace. Window, and then the first thing I usually finagle is X scale, which is the width of each bar. So I usually make it, for this it's like a dot plot. It's 1 wide. So I like going with 1 wide. Because it's nice. I mean, if you can get that much precision and shape, then it's like a win-win situation. Then, the only reason I changed anything past that, Candace, was this was at 73.8. And then you see how that last bar kind of gets chopped? That bugs me as a German. Germans like things like kind of compartmentalized. I'm mostly Italian, you guys have figured that out already. But I'm also part German. And I like things kind of exact. It's kind of strange, maybe, that it has to go to 74. And the highest value you guys said was 73. Does that upset anybody? Maybe a little bit? So I have a good reason for it. If it doesn't upset you, that's fine. But just so you know, the TI is set up for all kinds of data, not just discrete. When I told you guys to round off my height to the nearest inch, the TI is prepared to go with even more precision than that. So if somebody had said, oh, I think it's 69.6 inches, then you would have been included in this bar, which goes from 69 to 70. If you said 70.2, you would have been in this bar. So it's set up for continuous precision, not just discrete. So that's why 73 is literally right there on the end, but if somebody had said 73.5, you would have been there. Does that make sense? Ish. Okay. So you know. Please, Candace.
One more question.
No, go ahead.
After you change those, what do you push to go back?
Just graph. Yeah, if you keep going back to zoom 9, it's going to keep erasing what you change, yeah. So basically, the key sequence is zoom 9 for starters, and then window graph as you refine. Zoom 9 is just get you in the ballpark. It's like the helicopter drops the Marines off. Then the helicopter's done. Never press zoom 9 again until your next data set. Cool? All right. Did anybody, first of all, on average, did you catch my height? Actually, 0th of all, before first of all, 0th of all. Should we trust the average in this data set, do you think? Would you trust an average of this data set? I have a vote for no.
I'm an outlier. I'm no.
No, careful, careful, careful. Not you. Would you, oh no, would you as a statistician trust an average calculated on this data set? Why or why not? And you can say, John, you can say anything you want. John, go ahead.
We don't have the actual result.
We don't, but we can get it. We can calculate the average, right?
Yeah.
My question is, should we?
Yes,
Why, Kel?
because all of your numbers are clumped together in a small group and there's no outliers.
She's already looking at the shape of the data and saying, Kelly thinks this is what? Bell-shaped enough. Which means it's not horribly skewed. Like the chicken egg data. Now, Anna's going, I don't know. It looks kind of skewed to me. Good for you, sister. Good for both of you guys. This happens often in statistics. One person says it's bell enough, one person says it's skewed. That's why today we're going to build multiple models for outliers. Let's go with the yes, who says yes, it's bell-shaped enough? Okay, let's make you guys happy first. Let's use Kelly's 2 standard deviation idea, shall we? Okay, here we go. So John, you're right. We don't have that average or standard deviation yet, do we? Go calculate it. Not by hand. Please, dear God, no. No. Use your machines. Use your machines. Or Excel, but you're probably not carrying Excel with you right now. Do you guys like learning Excel? Okay, I heard one groan first. I apologize for that. Oh, I'm sorry, Aaron. I didn't mean for that to happen. Damn it. You have a Mac?
It's Linux.
Oh, it's better than a Mac. Shoot.
Google Docs.
Can you, Google Docs? Yeah, Kendra had the solution of using Google Docs, which probably is the way to go. I'm sorry, man. Linux is so smart, I can't imagine it couldn't pop it open somehow and do a conversion. It just can't. Google Docs, you're right, Kendra. You're right again. Candace, go.
Can you put up how to calculate it?
Yeah, for sure. Let's do it. Let's do it. So, friends, I'm on the phone with you. I'm doing my homework. How do I get the average? What do I press? Kevin, help me. You have a TI-99. I can't talk to you. Linux.
Right?
1 bar stats. Where is that? Where is 1 bar stats? Stat. Calc. 1 bar stats. Excellent. Press enter. Good. The average is 71. No. Don't you erase that, Joey. Watch what I just did. I went calc, 1 bar stats, enter. I did it wrong, didn't I? Because look, the TI thinks there are only 5 people that voted. What did I forget to do? I forgot to do L1, L2, correct?
Yeah.
I forgot to tell it that I have frequencies that Kendra mentioned earlier. I got to go L1, L2. Did anybody do the quizzes for this week? Did anybody? I don't expect most of you to have done it, but there was one quiz where you had bell-shaped data, and you actually had to do it this way to get the averages.
Why do you have 22 out of 21?
So how do I get to
That's left over from last class. Here we go.
How do
There
I
it
get
is.
to
That's what I got.
So you go right.
So, notice the average is close to doing it wrong, yes? The average is close to if I had done it wrong. That's because the data is roughly symmetric, centered on that middle value. It looks like you guys, on average, called me about 71 inches. On average, you guys called me about 71 inches.
How do I change that?
Your standard deviation of your guesses was just about an inch. I'm rounding these off to 1, to the nearest inch, only because that's what I had you guys give me as precision, so I'm sticking with that.
Right.
Hopefully that's fair. Decent? Believable? Okay. Now, based on your results, X bar 71 inches, S 1 inch, did anybody in this room call me either too short or too tall by Kelly's definition of outlier? Tell me, Linda.
The 73 would be an outlier
Because why?
because the second standard deviation would be 2.
2 inches.
So 70 or 71.
71 plus 2 inches. No, actually, you bring up a good point. So,
70.
no, you bring up a good point. So what Linda says is, okay, the average was 71, which if you're looking at the graph, is essentially right there. Essentially. If you add 2 to that, 2 inches, 1, 68%, 2, 95%, you've gobbled up all the guesses, haven't you? 71 minus 2 inches is 69 inches. That was the lowest guess. So that's the lowest guess, but it's not too low. and 71 plus 2 inches is 73 inches, which was the highest guess. That means all your guys' guesses were within 95%, or actually all of you, 100% of you, were within 2 standard deviations, which means that none of you had unusually high or low guesses. Well done.
Right.
Somebody yesterday said I was 6'7", or 6'5", excuse me, 6'5". I'm like, wow, with the hair down.
Huh.
Like 6'5". I was like, okay, it's all good. Extra 5 inches.
I have a son.
I'm actually 5'11 and a half. 5'11", I've never hit 6 feet.
Whoa, wait a minute.
So you got,
thought it was
or 3/4, whatever. Well, it depends on the time. It depends on the time of day.
I know, because later in the day you're
Later in the
shooting.
day, you're shorter, right? Gravity wins. Later in the day, pulls you down.
Big wing.
5'11 and 3/4, 5'11 and a half. I've never hit 6 feet, even with the hair. Well, with the hair I do, but that doesn't count. So you guys did a pretty damn good job. You called me 71. I'm actually about a half an inch, 3/4 of an inch bigger than that, on average, early in the day. Nice job. Did a nice concise estimate of my height. Yes.
So was I doing something wrong because I was wanting to take the average and subtract the median and then divide it by the...
You're talking about skew. Thank you, Candace. What you did was calculate skew. You were testing Kelly's idea
Okay.
that it's not bell-shaped enough. So what Candace is doing is she's going to that, if you did the quiz for this week, or if you looked at the quiz before throwing it away because it made you vomit, there's something called a Pearson's second skew coefficient, PSSC, referred to on the quiz, that allows you to give a numerical value to the skewness of a curve, a set of data. And what you do is you subtract the average from the median and divide by the standard deviation, and that kicks out a number that then is compared on a chart for skewness. So you would take the 71, let's see what the numbers were. Oh, it ends up being 0, which means essentially it's perfectly symmetrical. If it's 0, that means there's no skew to talk about. It's 0-ish, right? Of course. Yeah, which means there's no skew to talk about, which means Kelly calling it symmetric was totally fine. That's all. You can totally do that. Is it okay that we don't do that every time we analyze data? You guys do realize you could do that. You can totally crunch the skew of a data set. Excel has a command called skew. That you can just type equals skew and then put the data in, close the parentheses, hit enter, done. Or I guess press enter. And it gives you the skew value that then you compare to a chart. Knowing you could do it, this is why I don't like doing it, just to give you a heads up. I don't like it because once you've calculated the value, which is inarguable, you then have to compare that value to a table. And the table will tell you, yes, it's skewed, no, it's not skewed, or yes, it's kind of skewed, but not terribly. Where did the table come from? One dude in a paper published, I think in the 1970s, Hildebrand. I got the guy quoted. He's in your variation homework if you looked at the variation extra resources. Who's Hildebrand? Who the hell does he think he is? I don't know. It's based on good statistics, but it seems like one person's opinion. It's kind of like the body fat percentage that I was telling you about a little while ago, the body fat percentage. We take that very seriously in health circles. That entire reference chart is based off, I found out recently, only 6 cadavers of Swedish Jews. They took 6 dead Swedes, stripped the skin off, weighed their fat, and weighed everything else, and got the percentages in that way. I thought it was 16, which was bad enough. Then I found out it was 6. We're going to ask Jenny today about it in total fit, because she knows the true number. But then I have to start wondering, like, how much faith should I put in this percentage if it's based off of 6 or 16 Swedish people? I'm Italian, with some German and some French Canadian, you hosers. I'm not Swedish. So how much stock? So Candace, a long answer to your question, this is why I don't worry about the calculation of skew versus just looking at the data and going, you know what? It looks bell-shaped enough to me.
Well, and I think it's starting to confuse me with the standard deviation.
And the standard deviation is one number that means something when compared to that average. Nothing to do with the median whatsoever. So that's why I keep focusing on. That's why on your exam you had to put it in words, right? What does the standard deviation mean? What did it mean? How many times did you use the word average in that answer? Good. Good for you guys. Take 5. You're getting glazed. Yeah, take a walk. Take a walk. Get some air in this room.